Welcome to another episode of the EvilTester show, and in this episode we're going to look at the test automation pyramid. You may have heard of it as the test pyramid. And we're going to look at the source of the model created back in 2008-2009, how it's been misinterpreted, and we're going to understand the heuristics that sit behind the model and how I interpret it now in 2023. So welcome, my name is Alan Richardson. You can find me at EvilTester.com. Now, I have never been a fan of the test automation pyramid or the test pyramid. It's been massively communicated in so many different ways that I thought it was a fairly meaningless model. Now, the model started in a book called Succeeding with Agile by Mike Cohen, and it was released back in 2008-2009. Now, it's kind of a different world back in 2008-2009 when we were automating. Selenium was very, very new. I think Selenium was still at 1.0. It was moving into 2.0. Most of the GUI automation tools that we had were proprietary language based. So they had their own scripting languages. There was a lot of record and playback. It was very hard to do GUI automation in a way that was reliable. It was hard to automate UIs at that point in time. And there were a lot of process issues involved in adapting to Agile with test teams separate from programming teams. We had still had a lot of outsourced testing when people were still trying to move to Agile, and it was a very messy environment. And this model is actually a reflection of all of those things combined. So over the years, I have not liked this model because it was not this model that I was being exposed to. What I was being exposed to were all the different variations that people had created for test automation pyramid. So this model by Mike Cohen has UI, service level automating, and unit level automating. All the variants I've seen are end-to-end tests, integration tests, unit tests, manual tests on top of UI tests, acceptance tests, and unit tests, end-to-end integration unit. These are not the same terms that Mike Cohen used in his model, which means that all the variants that we've seen over the years are different models. They're reinterpretations, but they all often just refer back to Mike Cohen's work. So they'll say, this is the test automation pyramid as created by Mike Cohen, and then show a completely different diagram, which has a completely different set of underpinnings and heuristics. And over the years, what has happened is that a lot of these models are created by people in testing, and they're trying to focus on the test part. The title of the model is the test automation pyramid. So we've focused in on test and tried to expand this model out to cover everything that we do in testing. How dare you reduce testing just to automating? When the focus probably should have been on the automation part of test automation pyramid, got rid of test entirely, called it an automation pyramid, then we would be discussing it in a very different way, and we would look at it in a different way, and I certainly would have looked at it in a different way. I now view this model as a kind of automated execution using X-unit coverage model. So it's a bit of a mouthful, so it's never going to take off. So I don't believe that Mike Cohen even intended his model to take off like this. I think it was a kind of throwaway diagram to make a point, a very simple point, in his book. So this is in chapter 16. It's not the core of his book, and it's not even the core of this chapter. So he's basically got a title that says automate at different levels. That's an important thing to do, and it really depends how you define levels. What does levels mean? So Mike creates a diagram that explains what levels mean. And he's got a UI level, a service level, and a unit level. People don't tend to use the term service level or service tests. So there's an ambiguity here that is really, really important and explains why it has been misinterpreted so much. I don't understand what service level means, so I'm going to call it API tests. I don't understand what it means, so I'm going to split it into system tests, integration tests, and component tests. Service level here means something very specific. One thing to make clear initially is the difference between a diagram and a model. This is a diagram at this point in time, and the only thing that is ever shared is the diagram. Then people explain it, and because the diagram is so simple, what they're explaining is the model. They're trying to then convey the model that they have, that they've mapped this diagram onto. The diagram is a model. It's a very simplified model of a deeper underpinning model. So when people discuss this, they're discussing the model that they have built around the diagram, all the things that are not present in that diagram. The UI level here doesn't talk about capture playback because that's not in the diagram, but it's in the model that underpins this diagram. So we have to be clear that we're making a distinction, and when people are talking about the test automation period and they show Mike Cohen's diagram, very often they're not communicating Mike Cohen's model, which this chapter does, or this section of the chapter does. So people interpret the different sizes of the triangle to mean different things. They interpret unit to mean something different. People have different definitions of unit testing. From this diagram, we don't know what people mean. They interpret the level names to mean something different because they don't know what service level means. They have API tests and they're not mentioned in here, or are they? Are they covered by the service level? We don't know. The diagram doesn't tell us, so people have a model that tells us what they think. And it also depends whether people interpret the triangle to apply to testing in general or automating. And the title is Test Automation Pyramid, so it's slightly confusing. And this is why there's so many variants of the diagram, because people are trying to create a visual representation of their model, but they still call it the Test Automation Pyramid. The Test Automation Pyramid, as created by Mike Cohen, is that. Anything else that we see is a Test Automation Pyramid as created by someone else, and it may be based on their reinterpretation of Mike Cohen's work, but it's not Mike Cohen's model. Now, over the years, I've had issues with this when I've seen this stuff presented at conferences, because people use this diagram to describe their test strategy. People use it as a justification for what certain roles are responsible for. Well, the testers are responsible for UI testing. The developers are responsible for service and unit testing. So they split it up. They make, and this leads to process problems. And Mike does cover that in his book. And then people take offense because, well, it's testing, but it doesn't cover exploratory testing, the work that we do as testers. That's not in here. How dare they reduce our work to some sort of automated execution capture playback? And I don't think that's the intent, and it's clear from Mike's book that that's not the intent because he has a section on exploratory testing. I've always not liked the communication of these models because I think when you want to describe your strategy, you should describe your strategy in a way that people can understand what you're doing, and so they can identify risks in what you're doing. They can review it. They can make sure that their needs are being covered, their concerns are being addressed. But if you use a pyramid like this, then they can assume that everything's covered. Were you covering everything through the UI service and unit automating? Because that's your test automation pyramid. That's your strategy. There's nothing there that says we have gaps, we have missing things, we are going to do all these extra processes. So clearly this looks like you've got the full coverage with this approach. Very often when people are looking at this model, they go, well, because it's a pyramid, everything builds on everything else. And it does to some extent, but it does in terms of not trying to do overlap between what's beneath, but to find the gaps in what couldn't be covered below. What is important to test or automate at this particular level is what's important in this diagram. And it doesn't often get conveyed through, certainly doesn't get conveyed through the diagram aspect. But the intent, I think, is that you're trying to achieve different types of coverage at the different levels. And you should only be attempting to achieve coverage at the level that is important. So don't try and use the UI testing to achieve coverage that you could do through the unit tests. These are the kind of things that the model is saying. It's not saying, and you need to have automated tests at the API level, and you have end-to-end tests. It's not saying any of that. It's just simply saying there are things that it is important to automate. There are things that you can easily automate at different levels in the architecture or the system. Use the most appropriate way of doing that. You will achieve coverage at the end. So one of the other issues with a diagram like this is it doesn't describe the process. Where do you achieve this? Is it during the build process? Is it after deployment? When would you test in an exploratory fashion? in conjunction with this. It doesn't cover any of that. So really this is about automated execution coverage through different architectural layers in the application. And depending on the tools that you have available to you and the technologies, you can now approach this in different ways. Now, when we do unit testing and we use an XUnit framework, so I'm old enough to know when there was XUnit frameworks, and it was the JUnit framework, the PyUnit framework. So we have a tool, a framework that will allow us to execute code against the application in different forms without actually spinning up the application or deploying it to an environment. Now we have things like test containers. We could spin up a emulated Amazon environment during our unit testing, make calls to that emulated Amazon environment, and do what would normally be integration tests or end-to-end tests that require being deployed into an environment. We can do that during the build and continuous integration process. So the technology that we have available can change this model and how we approach it, and change our definition of unit testing or service level testing. And chances are what I described there, spinning up an Amazon environment using test containers, would apply into the service level, because it's where things integrate. We no longer live in 2008. We now live in 2023. Our models should change and adapt, but the heuristics that underpin this model are still valid. Don't try and do all your automating at one level. Don't necessarily use one approach to try and achieve all the coverage you want from your automated execution. The reason I'm saying that this is an XUnit automated execution pyramid is because there are other types of automated execution that we might want to do which aren't really covered here. So there's no performance, stress, security, concurrency testing here. They're part of our automated execution approach, but they're not covered in this diagram. So this is really focused in on what we would do for XUnit frameworks. And I'm now viewing this as the execution that we would do during our CI processes. Performance and stress sometimes are covered by the CI process, and they can be driven through XUnit style tests, and you can do concurrency testing there. You pretty much have to build your own framework to do it, but it is possible. But then you might still want to do some additional performance and stress tool on the application when it has been deployed, so that you can see if there's any additional risks when it's in the actual environment that it's going to run in. So if we had unit tests, which tend to cover classes in isolation, then we have to decide, well, what risks are there? I've tested these parts in isolation, but how do they interact with each other? And that's where the service level automating comes in. How do the different parts connect to each other to see if there's any risks there? Then the UI would be, okay, now that it's all hanging together, now that it's running as an application, how can I test the user experience? But it's more likely to be, but remember, we can also do unit tests in the UI. If we have functionality that is uniquely related to the user interface, that can be covered by unit tests. So what we're looking at here is at each layer of the architecture, what are the integration risks with the next architecture level? That's what this service is. When we view the application as offering services to us, which are integrated input, process, output, where the process involves lots of little units and possibly other services, I want to target that integration, which means that the service level actually has multiple levels within it, which is why people have split that out into API testing, integration testing, end-to-end testing, whatever else. Now, because it's 2023, again, we can do a lot of this work in the build process. If you're using Spring, then Spring has various annotations that will allow you to bring up a full application context. So one of your unit tests can have the application pop up in the background, which means you can then issue HTTP calls on the application running without a deployment. So you can do HTTP API level tests within the build process, within the unit. So it's probably shouldn't call it the unit process, because a unit test is so describing the testing of a class or the integration of classes, because we have very vague terms. So we very often describe unit testing to mean the execution point in our process. We're running the unit test, but we also use it to mean the scope of that unit. And the scope of that unit might be a class. It might be a higher level class that integrates other classes. It might be testing classes independently where any interfacing class is mocked out. Vague terms. So I used to look at the test automation pyramid in terms of architectural interface points. which is fine. That's my interpretation of it, but I don't think it's really what this was intended to convey. So by that I mean we have multiple interfaces. There's the API level interface, which makes HTTP calls, and we would have to look at the risks that need to be covered at each interface technology. But sometimes they are at the same level. A user interface isn't necessarily guaranteed to use the same API that is available externally, which means that the UI and the API don't build on each other. They build on the functionality beneath them in the service level. So essentially the API and the UI could be peers in a pyramid in order to achieve coverage. It really depends on the application you're testing. So if you use a pyramid model as your approach, you're really missing out the opportunity to model your own application, and you need to decide how you're going to achieve the coverage at each of your architectural levels or architectural decisions, how this thing hangs together. And then you can create your own model for that. And it's probably not likely to be a test automation pyramid. It's more likely to be a graph or overlapping set of circles, which shows what you're trying to cover where. The key points are, as a heuristic, you're not going to have the same level of automated execution coverage each level, and you probably shouldn't try and achieve all your execution coverage at the UI. There are probably more appropriate places to achieve that coverage. So this all seems fairly obvious. So why would we need something to remind us? Well, most of the time we don't, but we work on projects, and projects have processes, and processes get in the way of doing this effectively. If you have an outsourced test team responsible for testing and building a regression test pack, then they may not have access to your source code. They may not see the unit tests. They may not be able to assess the unit test coverage and decide what they're going to automate through the UI level. If they do, and the development team then get rid of a whole bunch of unit tests and there's a lack of coverage, who is going to get blamed for that? Right? When you split up the responsibility for achieving coverage between different teams, there needs to be a lot of communication. So what this highlights is if you are having to do a lot of tests through the UI level because that is all you have access to, then chances are you have a process problem. And the process problem is not going to be solved by adding a lot of unit tests. You solve the process problem by changing the way that you conduct and organize the project. Sometimes even if everyone's working on the same team, you can have problems because programmers work on stories. Testers automate in parallel to the programmers writing code. So they only have access to what they believe is the external capabilities, and they're not automating based on technical risk. They're automating to cover the acceptance criteria in the story. At the same time, you might have people who are dedicated as SDETs, and they will span releases rather than working on stories. So they work outside the sprint, essentially, to achieve execution coverage outside the sprint. Again, it's an organization of how you work on the project that impacts this as much as your technical levels that you're going to automate at. So very often now it's process management approaches and team structure that lead to situations where the automated execution looks unbalanced. Because we know now that we want to do as much coverage at early points or fast points or smaller points as possible. And we have the tools now to do that. Now the problem is we also have UI tools that can help us do a lot more coverage a lot easier with no programming knowledge. So that might start to edge people over to doing more testing at the UI level than the unit level because it's now much easier to do that. But again, that's a process problem where people don't necessarily know how to achieve the coverage they want. They're focused on roles and they're focused on what is possible for them to do without communicating to other people. So let's look back at Mike's actual words, the actual model that we have in here. The reasons given for not automating at the UI level is that they're brittle. They don't have to be. You can add a lot of synchronization, but certainly in 2008, they were very brittle. They were expensive to write. Why? Because a quick capture and playback approach to recording user interface tests can work, but tests recorded this way are usually the most brittle. Yeah, but who does capture and playback now? That was the norm back in 2008 and 2009. It's no longer the norm. And Mike does say here, writing a good user interface test that will remain useful and valid takes time. It still takes time. But what we're saying here is that it is possible. it is possible to write UI tests that are not brittle, that are not flaky, that can survive changes, that are easy to amend through abstraction layers. Part of the reason that this model is presented here is built around time. And the time we're talking about here is the time it takes to create, the time it takes to keep it running and amend it when something changes, and the time it takes to actually execute. Now, nowadays, with all the tooling that we have, it is possible to create a what would be called unit test run, which is incredibly time consuming by spinning up lots of Docker containers, doing a lot of interface testing and connection tests in that unit test run. That's still possible, and it's still possible to have a really time consuming build, even though all your execution is done through unit tests. So it's not so much the level that you're testing or the framework that you're using. We can structure our build process such that things run periodically, that things run in parallel. But certainly we don't have to deploy everything in order to test it, which is really what makes this time consuming. But we no longer have to deploy everything in order to execute it. We can do a lot in the actual build process, so the time consuming can be addressed even if you're doing UI tests. But this was absolutely valid in 2008. Things have changed. So brittle is no longer really the reason why we would avoid doing it. The real reason why we avoid doing this is because we want to target the execution coverage at the place where that functionality exists. That's it. Fundamentally, that's it. And if you're not using that to decide how you automate, then you are not thinking through. And that model, that diagram at the top, is really saying, think through where is the best place to achieve coverage, think through what the risks left are, then figure out the next best place to automate to achieve coverage so that you have some feedback on that functionality. So another point here is testing an application at different levels is partially redundant because you have coverage at different levels or layers, or functions use other functions, objects and classes are built from other objects and classes. So think through where the best place to target the actual functionality tested. Then your service layer, which is very vague and generic, basically says, okay, so given I've tested all of this at the bottom, where's the most effective way for me to test the interaction between these units? How can I test that these things work in combination? And when you're testing that they work in combination, you're no longer trying to achieve full coverage because you've achieved that at the unit level. You're trying to achieve the coverage of the interface and address the interface risks. And Mike actually says, although I refer to the middle layer of test automation paradigm as the service layer, I'm not restricting us to using only a service-oriented architecture. All applications are made up of various services. In the way I'm using it, a service is something the application does in response to some input or set of inputs. Right, so it's basically anything that coordinates or helps other parts of the system interact together is the service layer. In theory, the UI is the service layer as well. In theory, an API is a service layer as well. But they very often require different tooling, so it might be worth making them more explicit in a diagram to say we take a slightly different approach when we're automating at the UI level than we do when we're covering the service layer that is built up of classes. We have an API. We take a slightly different approach when we're automating through the API than when we're testing the service layer made up of classes. So you call it out because it's requiring different tooling. It's a different architectural level. It's a different it's a different interface into the application. We call it out as requiring specifically focused execution coverage because it's a different technology and has different risks and interfaces with the system in a different way. So though Mike Cohen here says, I'm not restricting us to using only a service-oriented architecture, people do create test automation pyramids that say API, integration test, and that's not really what this is talking about. Okay, so Mike does address process issues. What he says here is, when adding tests late, we're often forced to over-rely on the top level of the test automation pyramid. Adding automated unit and service level tests is too difficult until some significant refactoring of the application occurs. So basically, if you're trying to automate after the thing is built, it may be too late to do it effectively at the unit or service levels within the application. So you end up automating from the external input, like the API or the UI, because you didn't make it possible to automate at the lower levels. or you didn't plan to do it in the sprint at those levels, so you gave the task to someone else, like an SDET or a tester, and said, will you automate? And that person is going to automate from the outside in rather than from the most appropriate point. So Mike does cover process issues lead to problems, which then lead to us creating automated execution at potentially the wrong point. And that can lead to problems longer term with maintenance. So it's not just about the level that you test, it's about the process that you use. So given all that, for me, it's hard to really understand how this became so popular. It's a very simple set of heuristics, but maybe it's because it's a very simple diagram, or maybe it's because people took offense at the test part in here, so then they constantly tried to adapt it to their particular view of where testing fits into a process. They tried to map service level onto their particular application and architecture. And it was never intended to do that. It was intended to be a very simple model. So I used to look at this and go, well, I don't like this because it's saying we need to have more unit tests than UI tests. And it's not about amount. It's not about more. It's not about counting number of tests. And I don't think that's what Mike Cohen's underpinning model actually says. I think Mike, although he doesn't use the word coverage, is talking about coverage. He talks about avoiding duplication and avoiding redundancy, which to me hints at coverage. It's not about number of tests, it's about coverage and achieving coverage in the right place. So if people talked about the model in terms of achieving coverage, to me I wouldn't have a problem with this. I don't think the original model was intended to do more than make a simple point. I think it's been taken out of context, changed, adapted, misrepresented, and that's caused a lot of trouble because people don't go back to the source. People don't take the time to understand the underpinning model. So people take a simple diagram that they think they understand and use that as their approach. That's not how you do this. You create your own model. You model your application. You model the coverage you want to achieve. You look at how best to achieve that. I think we should stop trying to frame this as a test pyramid. This tries to then push this into a test domain. What we're really talking about is part of our strategy for software development and achieving coverage. If you remove test from the description, it becomes a much more accurate model, an automation pyramid. I don't like the word automation, so I would say an automated execution coverage pyramid. Automated execution also covers performance, stress, potentially linting, automated security testing tools. So I'm going to then reframe this as the automated execution X-unit coverage pyramid because I'm going to focus it in. I think we need to narrow the focus of this model rather than try and expand it. However, if you want a good analysis of a pyramid type model applied to testing, then James Back has a round earth test strategy presentation. You can find that on his blog post, and there's a couple of videos of him doing a talk about it. I'll link to some of those in the show notes. But if you want to apply it to testing, that is a very good representation of how you might apply this pyramid style thinking to the entire test approach. For the Mike Cohen's model, I think we need to restrict it down to an automated execution approach and ignore the test concept. Look at automated execution coverage, and this works fine. So I'm just summarizing my thoughts here, and my earlier version to this was about all the blog posts that's saying you must never test at the UI testing is bad, stop doing end-to-end testing, you must prefer API above UI, when the actual concept is we want to achieve a lot of coverage through automated execution. We want to achieve that coverage in the most appropriate way, because then we reduce the impact of change and it's faster to create the execution and code, and it's faster to execute when we use it in our build process. So we're prioritizing maintenance, longer term speed, and we do that by targeting the level 2 test. When we target a specific level, we know there are integration risks with levels that build on top of that, so do less testing at that level. But target the integration risk. That's the model, but that was never presented in any of the real blog posts that I saw in any of the models. So I had a real aversion to this, but having reread the original source, I don't have an aversion to this. I think this model is absolutely fine for the restricted domain that it actually tries to cover. Okay, so let's wind up. I don't really have a problem with this model anymore. Unit testing isn't a panacea. You still have to learn to do it well. It is possible to create brittle unit tests, so try to avoid that. That's not covered in this model. It's just common sense. Coverage doesn't just mean code coverage. It also refers to risk, functional coverage, requirements coverage, integration coverage, the functionality. So this model is too simplistic for that. You have to model your own application, identify the risks, and create approaches that cover those risks, that cover the code, that cover the integration points, but more especially cover the functionality at the point that that functionality is introduced. If that functionality only exists in the UI, then you're going to have to do some testing at the UI. Remember, it is possible to do unit testing of the UI, so maybe you introduce unit tests there too, and it doesn't all have to be done through a tool specific for that architecture layer. When we look at this, levels actually, they're peers. Like API is sometimes a peer to the UI because the UI doesn't use the same functionality as the API. They're actually technical interfaces, and it's important to recognize that technical architecture changes how we automate and achieve the coverage. So rather than just assuming that a UI builds on top of an API, it's important to understand your application. Otherwise, some of the reframed models that you see about UIs sitting on top of API tests will mislead you. A UI does not guarantee that it's using the API. API might hit different parts of the system. It might synchronize in different ways. So there's no guarantee that a pyramid model is actually going to map onto your application. It's really important to understand how your application is technically architected. Nowadays, it's not so much the tooling and the level that impacts our ability to achieve the coverage. It's more the process that's in place. It's how people are interacting, what levels of knowledge they each have, and how well they communicate to share that knowledge across the team. If you do not have effective coverage, if you have automated execution that is failing a lot, look at your process and how you are building these coverage approaches up. That's more likely a problem, and that is actually covered in Mike Cohen's Succeeding with Agile book. It's just not necessarily covered by this model. Diagrams are different from models. It's really important that whenever we see a diagram that we try to understand the underlying model, and every subsequent communication that I've seen about Mike Cohen's model is not actually related to Mike Cohen's words. So all my aversion to the test automation pyramid was nothing to do with actually Mike Cohen's presentation. It was to do with the misrepresentation and reinterpretation, blaming it all on Mike Cohen's work, which I think is really unfortunate, because Mike Cohen's work presents a couple of heuristics, and the heuristics might be a better summary than the diagram or model. So try and achieve execution coverage at the most appropriate level in your system, the most appropriate point for that functionality. Then consider what interfaces with this functionality, and then try and do a little bit extra coverage at that integration point, and that extends throughout your application. So that I think Simon Stewart in one presentation said the best way to have a WebDriver UI test is just to have one. Right, that would be an extreme. At one point in the application, we spin up the application to make sure that the UI works and we can integrate with it. We want to achieve coverage at the most appropriate place to achieve that coverage. Those are the heuristics that this model is trying to communicate. All right, so I know that was a little bit rambly, but I was just trying to come to terms with the test automation pyramid, which I now think of as the automated execution coverage pyramid, and I have no problems with this anymore. So if you found this useful, remember to subscribe at EvilTester.com. We also have a Patreon program that for only $1 a month gives you access to a huge amount of content, including online courses, recordings of test conferences, workshops that I've given, tutorials, training, and ebooks, massive amount of content. Check over at patreon.com/EvilTester. And hopefully I'll see you in the next podcast as well. EvilTester.com/show.